Okay, let's dig into this. We're talking about a situation where, failure isn't really an option and speed is absolutely critical. Think about managing like 18 different 4K video sources going to 18 different screens, maybe in a huge sports bar or, I don't know, a command center. It gets complex
Oh,
fast.
absolutely. It's a major challenge for AV integrators. And to kind of cut through that complexity, today we're doing a deep dive on a specific piece of gear, the WolfPack 4K60 18 by 18 modular HDMI matrix switcher chassis. We've looked at the specs, the documentation. Our goal here is really to get past just the list of features. We want to understand the why behind it. Why modularity? Why is that switching speed so vital for these high-end systems?
Yeah, and the specs themselves are, well, pretty impressive right off the bat. We're talking true 4K at 60 hertz with 4.4.4 color. That's the good
Yeah.
stuff, right? Pushing 18 gigabits per second. And it's designed for that big 18 ins, 18 out setup. But for me, the thing that jumps out is that performance claim, switching in about 100 milliseconds seamlessly.
Right. And that 100 meters figure isn't just marketing fluff. It really solves one of the biggest headaches in these large AV setups. But before we get into the speed, we probably need to look at the foundation and the hardware itself.
Exactly. The sources really emphasize that it all starts with the chassis, this 4U rack unit. It's
Yeah.
modular, right? It's got this backplane design.
Yep. It's built to hold 18 input cards and 18 output cards. They just slide right in.
So it's not just an empty box. It's engineered for this flexibility.
And what's really interesting is that the backplane itself is kind of like a universal translator. The big advantage of making it modular like this is you're not stuck with just one signal type, like HDMI. You can slot in cards for older stuff, maybe VGA or DVI if you need it, or specialized feeds like fiber, SDI, even composite video, YPBPR, audio.
Okay, so let's say you're running control room. You've got maybe a dozen new 4K computers, but also 6 older security cameras putting out, I don't know, analog signals. This matrix means you don't need a pile of external converters and power supplies cluttering things up. It's all handled inside this one box.
Exactly. Everything gets standardized and switched right there in the chassis. It simplifies the whole setup enormously. And, that modularity has a huge impact on reliability and the system's lifespan. This is really important when you think about the cost, because the cards are single port and hot pluggable.
Hmm.
Let's say you lose a signal on one input, or maybe a card actually fails.
You just pull that one card out.
Right, you just swap that one specific card. The other 17 inputs and 18 outputs keep running. The whole system doesn't go down.
So you don't have to power down everything or send the whole big heavy matrix back for repair just because one port has an issue.
Precisely. That's a massive deal for uptime, especially in places like casinos or data centers where things need to run 24/7.
Okay, that makes sense. Let's circle back to the video quality. You mentioned 4K 60, 4.4.4. Why is that specific combination, that color space, so important in, say, a professional environment?
Well, if you're just watching movies, maybe 4.2.0 or 4.2.2 color sampling is fine.
Hmm.
But when you're dealing with computer signals, detailed graphics, text, spreadsheets, anything with fine lines,
You need all the color information.
you really need that 4.4.4 sampling and make sure every single pixel gets the right color info, text stays sharp, it doesn't look fuzzy or smeared. Getting that level of detail while also supporting the latest copy protection like HDCP 2.3 and the HDMI 2.0 standard at 18 GBPs, that's what defines high performance here.
Okay, performance. Let's tackle that seamless switching claim again. 100 milliseconds. It sounds fast, but is it really instant? Can you actually see the switch happen?
For all practical purposes, no, you can't see it. The reason older non-seamless switchers take several seconds,
Yeah.
you get that black screen or snow.
The annoying pause.
Right. That pause is because the source device and the display have to basically reintroduce themselves every single time you switch. They renegotiate their capabilities. It's called the HDCP handshake and EDID exchange.
So what's the trick here? How does this WolfPack do it so fast?
Well, the sources suggest the processor inside is clever. It essentially handles those handshakes with the source and the display at the same time. It uses an internal buffer to hold on to the video signal information during the switch.
Gotcha. So it doesn't have to start from scratch each time.
Exactly. It holds that signal, so the switch is basically an instant cut from one frame to the next. There's no delay for renegotiation. That's how you get down to that 0.1 second transition.
Which is huge for that sports bar example. Nobody wants to miss a play because the screen went black.
Absolutely. Or, in a critical control room, you need that instant visual information. And importantly, the sources say it does this without adding any latency, any delay to the signal during normal operation.
Okay, so beyond just routing signals quickly and cleanly, this matrix seems to have more tricks up its sleeve. Signal management features, like the built-in video wall processor.
Yes, that's a big one. A lot of matrix switchers just route signals, point A to point B. This unit actually has processing built in to create video walls. So if you have, say, 4 screens you want to act as one giant display, you can often do that directly with this matrix. You don't necessarily need a separate, expensive video wall controller.
And that includes some creative options too, right? I saw something about rotating the image on the output cards.
Yeah, the 4K 60 HDMI output cards can rotate the image 90, 180, 270 degrees. You'd control that using RS-232 commands.
Which would be essential for digital signage, right? Stores often use vertical portrait mode displays.
Exactly. It means the matrix handles the rotation, so the video signal is already oriented correctly when it hits the screen. You don't need special software or players to do it.
And what about dealing with mixed resolutions, like that old VGA source going to a new 4K screen? There's scaling involved.
Yes, up and down scaling. And the sources mentioned this is handled right on the input and output cards themselves, often adjusted with DIP switches or software. The key takeaway here, rather than focusing on how it's adjusted, is that the matrix is smart about handling mismatched resolutions.
So it smooths out the bumps.
Pretty much. It makes sure a lower res source can display properly on a 4K screen or vice versa, minimizing compatibility headaches across all your different devices.
Okay, video sorted. What about audio? Sound is obviously critical in many applications.
Right, and the modularity helps here too. Each card, both input and output, has options for handling audio separately. It uses standard 3.5mm connectors. So you can take audio from a separate source and embed it onto the HDMI signal going into the matrix. Or on the output side, you can de-embed the audio from the HDMI signal and send it to a completely separate sound system, like amplifiers and speakers.
Ah, so you could route the video to the screen but send the audio to a high-end surround sound system, for example.
Precisely. It gives you real flexibility to manage the video path and the audio path independently. Crucial for places like churches or, really nice home theaters.
Now let's get to what the sources call the aha moment for AV folks. EDID management. We kind of touched on it with the seamless switching, but can you break down what EDID actually is?
Sure. EDID stands for Extended Display Identification Data. It's basically the little packet of information that a display, like a TV or projector, sends back to the video source. It tells the source, hey, here's what I can handle, my maximum resolution, frame rates I support, color depth, etc.
Okay, so it's like the display introducing itself to the source.
Exactly. And if that introduction, that EDID conversation doesn't go perfectly, that's when you get problems.
Yeah.
Flickering video, snow on the screen, or sometimes the source just gives up and sends a really basic low-res image because it's not sure what the display can handle.
And with 18 screens connected, the odds of one of them having a wonky EDID conversation seem pretty high.
Very high. So this matrix acts like an EDID traffic cop. It offers advanced management. Integrators can choose from several preset EDID modes to basically force the source to send a compatible signal. Or they can even copy the EDID from a display that's known to work well and have the matrix present that good EDID to the source.
So it pretends to be the perfect display.
In a way, yes. It has a built-in ED emulator or repeater that actively manages these handshakes. It helps prevent those common issues like resolution drops or weird color problems before they even start, and make sure the source always thinks it's connected to a capable display.
And just to round out the hardware reliability side, there's one more safety feature mentioned, dual power supplies.
Yeah, that's built-in redundancy. Simple but critical. If the main power supply fails for any reason, the second one kicks in automatically, instantly, no interruption.
So combine that with the hot swappable cards,
Yeah.
It really speaks to keeping the system running no matter what.
Absolutely. That's essential for those mission-critical 247 operations we talked about.
Okay, so we have this powerful, reliable box in the rack. But you've got 18 displays, potentially scattered all over a building or campus. How do you get the signal there? You're not running 100-foot HDMI cables, right?
Definitely not. That's where HDBaseD comes in. It's basically the standard way to send high-bandwidth HDMI signals, uncompressed, over long distances, using regular network cable. T6 or T7 cable.
Right, the stuff that's often already run throughout buildings.
Exactly. HDBaseD lets you push these signals reliably up to 70 meters. Sometimes even 100 meters, depending on the specific HDBaseD extenders you use with the matrix cards.
So the matrix can sit in a nice, cool central equipment room, and the screens can be way out on the floor of a casino or throughout a shopping mall.
Precisely. And another huge advantage of HDBaseD is something called POC, or power over cable. sometimes called PoE, Power over Ethernet, but in this context, it's often PoC,
Meaning?
meaning the little receiver box that sits behind the TV at the far end doesn't need its own power adapter plugged into the wall.
Ah, the power comes down the same network cable as the video.
Yes, it dramatically simplifies the installation at the display end. Fewer cables, fewer power outlets needed, fewer points of failure.
That makes sense. Now, there's a practical tip in the source material for installers about the cabling itself. Shielded cable.
Yeah, that's important. Because HDBaseT is pushing so much data, it can be susceptible to electrical noise, or EMI electromagnetic interference. So, if the network cable runs near heavy electrical equipment or conduits, using shielded C6 or K27 cable with proper metal connectors helps prevent that interference from causing, like, random video glitches or signal drops. It protects signal integrity.
Good tip. Okay, so the connections are sorted, the signals are getting where they need to go, but how do you actually control this beast? Managing 18 inputs and 18 outputs sounds like it could be complicated.
Right, and this is a point the sources really stress. After you figure out how many inputs and outputs you need, the next critical question is how you're going to control it all. And this is often overlooked initially.
So what are the options here?
Well, there's a whole range, which is great. You've got the basics, buttons, the front panel, sure, but also a built-in Web GUI. You can just log in from any web browser on the network. And standard control ports like RS-232 serial and network TCP-IP for integration with other systems.
Okay, so standard professional options.
Yes, but it goes further. They offer free control apps for pretty much any phone or tablet, iOS, Android, Amazon Fire.
So you could potentially use a cheap tablet as your main controller for the whole system.
You absolutely could for many scenarios,
Yeah.
which is pretty cool.
And what about integration with the big professional control systems, like Crestron, Control4?
That's covered too. The sources say they provide drivers or modules, often free, for all the major players. Crestron Control4, ELAN, URC, RTI. This is key because it means the WolfPack matrix can slot right into an existing automation system in a large facility or high-end home. It speaks their language.
So it plays nice with others.
Definitely. And it also means that skilled integrators can write their own custom control software using the RS-232 command protocol. They even give an example in the documentation.
Yeah.
If you want to switch input 8 to display on outputs 1, 8, and 16 all at once, there's a straightforward command for that, like 8 by 1 and 8 and 16.
That level of direct API access is important for really custom setups.
Critical. Think about that casino again. They might need a custom button push on their main control panel to instantly switch all TVs in the poker room to a specific tournament feed. That detailed API allows that kind of complex, tailored automation.
Okay, so we've covered the tech, the features, the control. Where does this kind of high-end matrix actually get used in the real world?
Well, the list is pretty diverse, hitting all those places that need reliable, high-performance video distribution. Sports bars are a classic example. Casinos, definitely. Data centers for monitoring multiple systems. Also large shopping malls for digital signage, places of worship with multiple screens, schools, university campuses, and of course, high-end, large-scale home theaters. Anywhere you have many sources and many displays.
Right. Anywhere that complexity and reliability are paramount. Now, for someone maybe considering a big project, like a whole house system or a smaller commercial setup, the sources mentioned a cost-saving tip.
Yeah, it's a common piece of advice from integrators, actually. The idea is to separate the hardware purchase from the software programming and installation labor.
How does that work?
Well, instead of getting one giant quote that bundles everything together, you could purchase the core hardware like this WolfPack matrix yourself, directly. Then once the physical installation is done, you get separate quotes from qualified control system programmers or integrators just for the specific task of writing the control software and commissioning the system.
And the thinking is that the custom programming part is often where a lot of the cost lies in these complex systems.
Often, yes. The hardware cost is significant, of course, but the hours involved in bespoke programming for Crestron, Control4, etc. can really add up. Separating the bids might give you more transparency and potentially lower the overall cost.
Interesting strategy, and it relies on trusting the hardware itself will be solid.
Which is why the manufacturer's testing process is relevant. The sources mention a 5-step procedure before anything ships: assembly, initial power-up tests, a 24-hour aging or burn-in period to catch early failures, final full functional testing, and then a last QC check.
So they're trying to build that reliability in from the start.
It seems that way. Building confidence in the core equipment.
Okay, so if we try to boil this all down, synthesizing everything we've looked at today, this WolfPack matrix seems to really stand on maybe Three main pillars. First, that modular design, providing resilience through things like the hot swappable cards and dual power. Uptime is key.
Right. Pillar 1, modular resilience.
Second, the performance itself. Getting that true 4K 60 4.4.4 quality, but crucially pairing it with that super fast 100 millisecond seamless switching.
Pillar 2, uncompromising performance, seamless speed.
And third, the control aspect. Just the sheer breadth of options, from simple apps to deep integration with professional systems, making it incredibly flexible.
Pillar 3, unparalleled control flexibility. It fits anywhere.
So wrapping this up, maybe a final thought for you, the listener, to consider. We've talked a lot about the benefits of this modular card-based system today.
Yeah, and thinking long-term, HD-based technology, video standards, they're always evolving, right? We're already seeing discussions about resolutions beyond 4K. New standards will come. So the question to ponder is, how much does this modular architecture, the ability to just swap out an input or output card for whatever the next technology is, impact the future-proofing and the total cost of ownership for a big AV installation maybe 5 or 10 years down the road, compared to a fixed matrix where you might have to replace the whole thing?
Something definitely worth thinking about when you're planning that next major